Okay, so we are going to talk about the quotient rule and then learn the other 4 trig derivatives in this section. So the quotient rule is for two fractions that typically can't be reduced in the beginning. So this is our derivative, which is a lot to remember. So as a shortcut, we typically let the top be high and the bottom be called low. And then we have a saying to help us, okay, right here. So it's g of x, so low d high minus high d low all over low squared, okay? And if you say that over and over again, it's actually pretty easy to memorize. So let's look at example 1. So this is high, this is low. So it's low d high. So we've got low, you're going to want to use parentheses since they're quantities. The derivative of the numerator is going to be just 5 minus high and then d low. So the derivative would be 2x and then all over low squared. This typically will just stay in factored form. You don't want to write that out twice and distribute, okay? So to simplify, this is where all the algebra strength comes in. We're going to distribute 5. And then this negative needs to be distributed, but also the 2x. So I'm going to actually make this a negative 2x. And then that's what I distribute. So you can do it all in one term. So minus 10x squared plus 4x all over this low squared. Okay. And then my last step is just to combine like terms. So in the numerator, now, for me, this is a perfectly fine answer, but the AP does not really like the leading coefficient in the numerator to be a negative. So what they will do, just so you know, is they'll factor out a -1, which changes all the signs in the numerator. They just like this to be a positive. You don't have to do this, but this question would be multiple choice on an AP exam, so if I don't mention it, it might throw some students off. This is what would be on an AP multiple choice, okay? For me, on a test or a quiz, if you were just writing it out, I'm perfectly fine with that. That's also one of the reasons I kind of like multiple choice questions. All right, number 2 is kind of tricky. You won't see this a lot, but what they've done is they have a fraction in a fraction, which from secondary 3, you learn is kind of, you're not allowed to leave your answers like this. So you can start by doing the derivative, or you can eliminate this fraction in a fraction before you do the derivative. It's really a choice. If you don't do it now, you'll have to do it at the end. So I'm just going to rewrite it, and then we'll do it at the end. You want to rewrite that as a power, so we can just use the power rule. Okay, so that's still the original. So if we take our derivative, we've got low. Now d high, well, 3 goes to 0. I'm going to bring the power down so it's positive, and then subtract 1. Low d high minus high d low all over low squared. Okay, so we are going to, the cleanup is going to be pretty tricky on this, but we're going to distribute. So remember, you add exponents, so we get x to the -1 plus 5x to the -2. This is like a -1. I'm going to change colors so you can remember I did it. So minus 3 plus x to the -1, and then our denominator stays the same. Well, these are going to be the same, so I'll combine. We get 2x to the -1 plus 5x to the -2 minus 3 all over this. That could be the multiple choice answer. You never know. They might rewrite this with powers. I'm really okay with this if it's not multiple choice. The 5 goes on top. Okay. Typically, if we want to follow the rules from secondary 3, we want to get a common denominator. So the common denominator is going to be x squared. So I would need to multiply by an x. That one's fine. I'm going to multiply by an x squared here. So we would end up with 2x plus 5 minus 3x squared all over x squared. And then that's all over this, which is really over 1. So then you multiply by the reciprocal. So 1 over x plus 5. So nothing will reduce, and we just write this as one fraction. So I'm going to write it over here. We would get 2x plus 5 minus 3x squared all over x squared quantity x plus 5 squared. This is the same as this, is the same as this. You just have to really be flexible if it's multiple choice. I think this one's the best answer, but we'll see. Okay? All right. Now, as a review, for basic trig functions, this is not calculus. Cosecant, remember, is the reciprocal of sine. Secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. We have our identities we left out. So tangent is equal to sine over cosine. With trig and calculus, you have to be pretty flexible on the multiple choice answers. They might use some of these identities to simplify it. They might not. The most common, there are 3 Pythagorean identities, but this is the most commonly used one. Okay? So the derivatives, I'll leave this up here. We've already seen this one and this one, but we have 4 more that we need to memorize. So the derivative tangent is secant squared. The derivative cosecant is cosecant times cotangent, negative. The derivative secant is secant times tangent, and the derivative cotangent is negative cosecant squared. So it really just becomes a memorizing game. The one thing that's missed the most often are the signs. So what you'll notice, I'm going to make this a little hint, is if the function starts with the c, its derivative is negative. Okay? So just keep that in mind. So original function if it starts with a c, the derivative is negative. And that's really the only pattern there is. You notice like secant has secant and tangent. Tangent has secant in it. I mean, there's other patterns as well, but the signs are the most commonly missed thing. So that's why it says with trig, there can be more than one correct answer. That's definitely why multiple choice is usually the strategy. Just be flexible always. So on our derivative, we're going to do the derivative 2x, which is 2, and then minus, I do the derivative tangent, which is secant squared. And that's it. Okay? This won't be an identity to simplify. On f of x, we can leave our functions as they are and then do a quotient rule. So low, d high, so I'm just going to write it as 0 minus the derivative of cosecant is a negative cosecant cotangent. Low d high minus high, and the derivative of secant is secant tangent. Yeah, it gets pretty complicated. All over low squared. Remember with squared, you can put it there. If you want to use a parenthesis, you're welcome to, but that's a good review. All right, let's start cleaning this up. The 0 I can ignore. 2 negatives make a positive. And what I do notice, if you can see this before you start, it'll save you a little bit of simplifying. We've got, this is all going to be one term. This is all one term. And then we've got one term here. And they all have a secant in common. So we're going to take one of the secants out. So that one's out. See, this is being multiplied. That's why I can take that out and take one of those out. So then I don't have anything to distribute. So we're going to write what we have. So cosecant, cotangent. And then I want to distribute this negative tangent. So minus tangent. And then a negative times a negative is a plus, and you just put these side by side. Cosecant, tangent. All over secant. Now, that looks like a pretty decent answer. This one's fine. It is a lot of trig words, so it's hard to say if that's going to be the final answer. We're going to just, I'll call it play around. In case this wasn't one of the available options on an AP test, this would be multiple choice too. So it's not like you'd be guessing, like, do I need to keep going? But we're going to try rewriting this. So to see if anything simplifies. Well, cosecant is 1 over sine. And cotangent is cosine over sine. Tangent, probably not since it's just by itself. And then here, cosecant. And so you're kind of like, ooh, we have a bunch of different denominators. So maybe they reduce this. Can't reduce that. And we don't usually want to write our sine squareds. Secant, they might change that. I mean, who knows? So as far as I know, you don't want a fraction. So I would say we're going to leave that cosecant, cotangent. And we don't want 2 trig functions. We're going to bring that back to tangent. But I can have 1 over cosine, which is secant. So maybe this is the multiple choice answer. I mean, at this point, you're like, I don't even know. Okay, so see how you can just keep manipulating it if your answer doesn't show up. All right, let's try number 3. So number 3 is one of the first times where we had to use the product rule. So 1, 2. So remember, it's 1d2 plus 2d1. Okay? So 1. The derivative tangent is secant squared plus 2. The derivative sine is cosine. So same idea. This could be our answer. If we play, so I'm just going to say play, well, we have sine, secant squared is 1 over cosine. That's not much simpler. Tangent, we would be able to reduce. So maybe they have, let's bring this back to sine, secant, plus sine. So then what happens is we can factor a sine out. 1, we get secant plus 1. So maybe this is the answer. Okay, and this looks like a trig identity, but remember it's 1 plus tangent squared equals secant squared, so that doesn't work. Either one. Okay. All right, so good luck. Play around with some of the trig. As you can see, it's not an exact science, okay? So good luck on your quotient rule.